Morning students. Today we are going to cover one more important topic, higher order homogeneous differential equations. So in a previous topic we solved homogeneous differential equation of second order. Very particularly they are homogeneous second order linear differential equations with constant coefficients. We solved that second order. In shortcut, what I am saying is second order homogeneous differential equations we solved. Now in this class what we are going to learn is how to solve higher order homogeneous differential equations. So, to be frank, what we are going to do, higher order homogeneous linear differential equations with constants coefficients. That's what we are going to learn today. So up to second order means second order we use a quadratic equation. Second order auxiliary equation is a quadratic equation. By finding the roots you can write the general equation, general solution we can find. But now higher order means order may be 3, order may be 4, order may be 5. So how to find the 3 roots or 4 roots or 5 roots? So if you are able to find the roots, then you can write the solution. So first of all let me give, so depending on the roots, how to write a solution for higher order differential equations. Yes. Linear differential equations of higher order and but homogeneous. Okay. So now depending on the roots, let me take 3 roots or let me take 4 roots. So for 2 roots we are given. Now very similar to the 2 roots, if 3 roots also the solution is very similar. So if you know in the first class, if you know how to write the general solution for 2 roots, the 2 roots may be real and equal, real and different, complex, third roots we are given in the first class. So if you know that, then it is very easy here to understand. So now let me start. Nature of roots, general solution. Nature of roots and general solution. You see, M1, M2, M3. M1, M2, M3 are 3 real and different roots. Are getting M1, M2, M3. The first one, M1, M2, M3 are 3 real and different roots. If two real and different roots, for 2 roots, we written C1 into e power of M1x plus C2 into e power of M2x. Now for M1, M2, M3, 3 real and different roots, what we are going to write? We are going to write y is equal to C1 into e power of M1x plus C2 into e power of M2x plus C3 into e power of M3x. So for 2 we are writing third one, C3 into e power of M3x. If they are 4, that is M1, M2, M3 and M4 real and different roots, then what? Then C1 into e power of M1x plus C2 into e power of M2x plus C3 into e power of M3x plus C4 into e power of M4x. If fifth root is there, C5 into e power of M5x. If sixth root is there, plus C6 into e power of M6x. That's it. Are you getting? This is very easy. If you know the 2 roots, you can write for 3 roots, for 4 roots, for 5 roots, whatever, how many may be the number. Are you getting? So I given in the slide only for 3 roots, but if it is 4 you can write one more term, if it is 5 another term, it is 6 another term, like that. Are you getting? So it is very easy. So look at that. If M1, M2, M3 are 3 real and different roots, then the general solution is y is equal to C1 into e power of M1x plus C2 into e power of M2x plus C3 into e power of M3x. Are you getting, guys? So this is the first case. Roots are real and different. Maybe 3, maybe 4, maybe 5, depending on the order of differential equation. If order is 3, you will get 3 roots. Order is 4, you will get 4 roots. So number of roots equal to the order of differential equation. Are you getting, guys? Now we see the second case. Second case are real and equal roots. Real and equal roots. If m comma m are two roots, in two root case, in previous class, what we written, if two roots are equal, we written the general solution is y is equal to c1 plus c2x into e power of mx. Now I am giving for three roots. If m comma m comma m, three real and equal roots, three roots are equal and they are equal to m, then how to write the general solution? The general solution is what we can write. The general solution is y is equal to c1 plus c2x plus c3x square into e power of mx, where m is a real and equal root. Are you getting, guys? Yes. m comma m, three real and equal roots, y is equal to c1 plus c2x plus c3x square into e power of mx. If m and m, that is four equal roots, four real and equal roots, m comma m comma m comma m, then what to do? c1 plus c2x plus c3x square plus c4x cube into e power of mx. If there are five equal roots, c1 plus c2x plus c3x square plus c4x cube plus c5x power of 4 into e power of mx. Are you getting? So if for three equal roots, I am giving in the slide what I given is, if m comma m are three real and equal roots, three roots are equal roots and real numbers, then the general solution is y is equal to c1 plus c2x plus c3x square into e power of mx. If there are 4, c1 plus c2x plus c3x square plus c4x cube e power of mx, like that. So for 3 I give it, for 4 you can write, for 5 you can write, for 6 you can write. So that is like so on. Now coming to the third case, they are complex roots. First case is real and different, second case is real and equal. Now the third case is complex roots, alpha plus or minus I beta, alpha plus or minus I beta. Now if two roots are complex and one root is a real number, then for one you can write c1 into e power of m1x, for the next to 2 e power of alpha x plus c1 cos beta x plus c2 sin beta x, that already known. Now the special one I am giving, if two roots are complex, one is real, you can write. Now there are four roots. What are they? Alpha plus or minus I beta, comma alpha plus or minus I beta. So repeated twice. The complex roots exist in pairs. I already told you, if alpha plus I beta is a root of an equation, then always alpha minus I beta is always a root of the given equation. So all complex roots always exist in a pair. So for a pair of complex roots, we given the solution, general solution in previous class itself. Yes, we are given in the previous class. Now the pair of complex roots exist twice, two times. They exist twice. Are you getting? Alpha plus or minus I beta, alpha plus or minus I beta are four roots. That's alpha plus I beta, alpha minus I beta, again alpha plus I beta, alpha minus I beta are roots of a given differential equation, in particular homogeneous. Now they are repeated twice, then how to write the general solution? The general solution is, remember here we are going to come across in a problems we are going to come across. So what is that? Is the y is equal to e power of alpha x plus into y is equal to e power of alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. So for repeated, they are equal, that's why we are using the equal signs, like that in equal case, however written, same thing we are writing, c1 plus c2x plus c3 plus c4x. If they are thrice c1 plus c2x plus c3x square, c4 plus c5x plus c6x square, like that you are going to use. Where you know it when equal roots how to write, so that's what. So concentrate on these three simple formulae so that we can go to the problems. Are you getting? So first one, nature of roots for higher order means number of roots are 3, 4, 5, like this. For 3 I given some different roots m1, m2, m3 are real and different. Then the solution is y is equal to c1 into e power of m1x plus c2 into e power of m2x plus c3 into e power of m3x, and so on. If roots are equal m comma m comma m, then the general solution is c1 plus c2x plus c3x square into e power of mx. For more also you can write in similar way. And for complex roots which exist in twice, repeated twice, that is alpha plus r minus I beta is two pair of roots, again alpha plus I plus r minus I beta, and is also the pair of roots, that is total roots are 4. Then how to write in this case? In this case we will write y is equal to e power of alpha x plus c1 c2x cos beta x plus c3 c4x into sin beta x. So these are things that how to write a general solution if number of roots are more than 2, that is 3, 4, like that. If number of roots are more, then how to write the general solution, that's what I given in the first slide itself. Because the what is the topic is higher order differential equation. So order is 3 means you will get 3 roots. If order is 4 means you will get 4 roots. If order is 5 means you will get 5 roots. So depending on the roots, how to write the general solution. If 3 roots, if 4 roots, if 5 roots, if the real and different roots, real and equal roots, and complex roots. In these cases, how to write the general solution I given in this slide. So concentrate on this. So when m1, m2, m3 are real and different roots, then how to write the general solution. M and m 3 real and equal roots, then how to write the general solution. If complex roots exist in a pair, so 2 pair of complex roots, alpha plus r minus I beta, again alpha plus r minus I beta, then how to write the general solution is given in the slide. So concentrate on these 3 rules, that real and equal, real and different, and complex, and the number of roots are more than 2, how to write the general solution. Now let us try to go to the problem so that you can easily understand the things very clearly. Now read it so that we can go to the next problems. Shall we go to the problems, as we are now going to solve problems? So similar type, but here what is that? The order is more than 2, higher order. We are trying to solve higher order. So whatever may be the order, what we need here is the roots. If you are able to find the roots, then you can write the general solution. I given in the slide when the roots are given, how to write the general solution. So take the equation, write the auxiliary equation, try to find out the roots. Once you are able to find the roots, then automatically you are going to write general solution. That ends the problem. Are you getting? So let us go to the problems. Another half an hour, so try to cover more problems. Okay, so this is my first problem. Solve. What is the problem? Solve. D cube minus 2d square minus d plus 2 of y is equal to 0. Yes. D cube minus 2d square minus d plus 2 of y is equal to 0. So what is an order? Order of given differential equation, its highest order derivative present in that. What is that? It is d cube, d power of 3. Therefore, order of given differential equation is 3. So, how many roots you will get? You will get 3 roots. As for order, you will get, order is 3. Therefore, you will get how many roots? You are going to get 3 roots. Are you getting? So, given equation is in operator form. Capital D cube minus 2d square minus d plus 2 of y is equal to 0. At place of d, put m and remove y, you will get auxiliary equation. M cube minus 2m square minus m plus 2 is equal to 0. This is, sorry, 1 minute, yes. So you got the auxiliary equation. What is the auxiliary equation is m cube minus 2m square minus m plus 2 is equal to 0 from first two terms. What to do? Take m square common. From m cube, m square common means m minus 2m square common means 2. So m square common, you will get m minus 2, and the next two terms, take minus 1 common, you get m minus 2 is equal to 0. So now next one, take m minus 2 common. M minus 2 common, remaining m square minus 1 is equal to 0. M minus 2 into m square minus 1. M square minus 1 can be written as 1 square, that is m square minus 1 square, a square minus b square, a minus b into a plus b. A minus b into a plus b. Are you getting? So what will get? M minus 2 into m minus 1 into m plus 1 is equal to 0. So m is equal to 1, m is equal to minus 1, m is equal to 2. You can write vice versa. Any way you can write. You can write first 1, second minus 1, third 2, or you can write 2 minus 1, 1, or minus 1, 1, 2. In which order you can write, it is right. No need to worry about the order of the roots. You can write the three roots in any order. Are you getting? So the roots are, you got the three roots. What are the roots? M is equal to 1 comma minus 1 comma 2. They are real and different roots. The roots are real and different. So how to write the general solution? So the general solution for real and different roots, you know that for each root you have to write one term, that is y is equal to, write the general solution. What is that? Y is equal to c1 into e power of 1 into x. 1 into x means x. c1 into e power of x plus c2 into e power of minus 1 into x, that is minus x, plus c3 into e power of 2 into x, that is 2x. So what is the general solution? The general solution is y is equal to c1 e power of x plus c2 e power of minus x plus c3 e power of 2x. Are you getting? So for the first problem, what is the first problem? What you got? You got real and different roots, 3 in number. That is higher order. It is a d cube. D cube means it is a differential equation of order 3. Once it is of order 3, it will have 3 roots. 3 roots, and all of them are real and different. Very first case. Okay. In previous class, we learned how to solve second order. Now we are solving higher order, that is order 3, order 4, like that. Many times you will get problem on order 3 only. So now the first case, real and different roots. Then how to write for real and different roots? 1 minus 1, 2 or 3 roots, real and different roots. Then the general solution is c1 into e power of x plus c2 into e power of minus x plus c3 into e power of 2x. That's it. So this is my first problem of order 3. So what I want to tell you is this slide. You use it now. What we used is, you use it the first one, real and different roots, then you have to write the general solution like this. If real and equal, then you have to write the general solution like this. If complex roots repeated twice, then you have to write the general solution like this. So this slide is important. That's why I spend much time on this slide, so that you can learn it very easily. I explained it. So very similar to the second order general solutions, so that's why you can easily remember, I think. So this is the first problem we covered, is d cube minus 2d square minus 2d minus d plus 2 of y is equal 0. We written the auxiliary equation, we took common, then we got 3 real and different roots, 1 minus 1 2. Then therefore the general solution is c1 into e power of x plus c2 into e power of minus x plus c3 into e power of 2x. So this is my first problem. So let us quickly go to the next problem. If you complete, we will go to the next problem, guys. This is my second problem. Solve d cube y by dx cube minus d square y by dx square minus dy by dx plus y is equal to 0. So again, what is order? Order is 3. If order is 3 means how many roots? You look at 3 roots. So first of all, what is our target? You have to find the roots. Once you find the roots, you can write general solution. So operator form. So at place of d by dx, put to d square y by dx square, d cube y by dx cube, capital D cube. So what is an operator form of given third order differential equation is d cube minus d square minus d plus 1 of y is equal to 0. So this is our third order differential equation in an operator form. Now write auxiliary equation at place of capital D, substitute p, put m, that is m cube minus m square minus m plus 1 is equal to 0. We got auxiliary equation 2. So now what to do? You have to find roots. Look at the first two terms. You can take the common as a previous problem. So what we can take common? M square common. If m square is common from m cube, m remains, from minus m square it minus 1. So m square common means m minus 1. Next two terms, take minus 1 common. It is m minus 1 is equal to 0. Are you getting? So from first two terms we are taking m square common, and next two terms we are taking minus 1 common. Now here take m minus 1 common. If you take m minus 1 common, remaining is m square minus 1. 1 can be times 1 square, that is m square minus 1 square. That is m square minus 1 square means a square minus b square. A square minus b square is equal to a minus b into a plus b. So what are you going to get? M minus 1 into m minus 1 into m plus 1 is equal to 0. So what are the roots? M is equal to 1 comma 1 comma minus 1. So we got the roots. Once we get the roots, it is very easy to write general solution, because we took the rules. Depending on the roots, how to write the general solution, we already know it. Now we got the roots. What are the roots? The roots are 1 comma 1 comma minus 1. The roots are 1 comma 1 comma minus 1. So the two roots are equal. And the third one is different. Two roots are equal, 1 comma 1, and the third root is minus 1, different from that. Those two. So how to write? For two roots equal, we can write the general solution. Y is equal to, for equal roots, c1 plus c2x into e power of x. Are you getting? c1 plus c2x plus c3x square, if three roots are equal. For two roots, c1 plus c2x into e power of 1 into x, that is x. For different root, for a different third root, you can write c3 into e power of minus x. So overall, what is the general solution? The general solution, y is equal to c1 plus c2x into e power of x plus e power of c3 into e power of minus x. Are you getting? So in the first problem, we got three real and different roots. That is the case. Now we got three roots, but among the three, the first two are equal roots and third one is different. For equal roots, for two equal roots, how to write the general solution, and the different root, how to write the general solution, and what is the overall general solution is this. The first two terms, first two for equal roots, and the last one is for third different root. This is the general solution. Are you getting? So this is my second problem. Yes, excuse me. Okay, this is my second problem. What is the time left? You see another 20 minutes, 20 to 25 minutes to go. So let us quickly go to the next problem so that we can cover more problems. So this is my third problem. What is that? Solve d cube minus 1 of y is equal to 0. What is an order? What is an order? Order of given differential equation is 3. Once order is 3, then how many roots? The roots are 3. So if you find those 3 roots, then you can easily write the general solution. So our target is to find roots. You see, what is our problem given? Third problem, solve d cube minus 1 of y is equal to 0. The problem is directly given in an operator form. So sometimes it may give in a general form and sometimes it may come in a operator form directly too. So whatever we have to write in any case, what you have to write? You have to write auxiliary equation. So put d is at place of d, you have to put m. So what is an auxiliary equation? The auxiliary equation is m cube minus 1 is equal to 0. Now, no common, no term to take common. But you can remember the formula m cube minus 1, 1 can be written as 1 cube, that is m cube minus 1 cube. M cube minus 1 cube means it is of the form a cube minus b cube. What is a cube minus b cube? I given the formula in the slide itself. A cube minus b cube is a minus b into a square plus ab plus b square. So this is my formula. A cube minus b cube is equal to a minus b into a square plus ab plus b square. At place of a we are having m and at place of b we are having 1. So write at place of a m and at place of b 1. So what will get? A minus b means m minus 1, a square, m square, ab, 1 into m, b square, 1 square means 1. So what is that you got is m minus 1 into m square plus m plus 1 is equal to 0. You get common. M is equal to 1. One solution got. Another two solutions. This is a quadratic equation. M square plus m plus 1 is equal to 0, but not possible to factorize. Therefore, go to the formula. M is equal to minus b plus or minus square root of b squared minus 4ac by 2a. Here a is equal to 1, b is equal to 1, c is equal to 1. So, m is equal to 1. M minus 1 is equal to 0 means m is equal to 1. Then for quadratic equation, m is equal to minus b plus or minus square root of b square minus 4ac by 2a. Substitute values of a, b, c is equal to 1. Now, what will get? M is equal to minus 1 plus or minus square root of 1 minus 4 by 2. 1 minus 4 means it is minus 3. So, m is equal to 1, comma m is equal to minus 1 plus or minus square root of minus 3 by 2. Square root of minus 1. What is square root of minus 1? Square root of minus 1 is I. Square root of minus 1 is I. So the roots are m is equal to 1 comma minus 1 by 2 plus or minus root 3 by 2 into I plus or minus. It is plus or minus. Plus or minus root 3 by 2. So one root is a real root and the other two roots are complex roots. Complex roots always exist in a pair. Are you getting? Complex roots always exist in a pair. So for one different root, m is equal to 1 you are having. So what is the general solution? c1 into e power of m1x, that is c1 into e power of 1x, that is c1 into e power of x. So this is for one different root and the other two roots are complex roots. For complex roots, how can we write? Alpha is minus 1 by 2, beta is root 3 by 2. Therefore, the solution is e power of minus 1 by 2 into x plus c1 cos root 3 by 2x plus c2 sin root 3 by 2x. Already we did in the last class for two roots. Same thing we are applying. So the general solution is this. Total general solution is y is equal to c1 into e power of x plus e power of minus 1 by 2 into x into c1 cos root 3 by 2x plus c2 sin root 3 by 2x. Are you getting? So one root is real root and the other roots are two complex roots which exist in pair. So for a real root, you can write c1 into e power of x, and for complex roots you can write e power of alpha x into c1 cos beta x plus c2 sin beta x. So this is how. So what is here? The important thing is that you have to find the roots. Somehow in previous problem we took common. Now in this problem we are used a cube minus b cube formula, that is a minus b into a square plus ab plus b square. So you have to remember all these algebraic formulas. You have to remember how to find the roots. If there is no factors, then minus b plus r minus square root of b square minus 4ac by 2 you have to remember. And depending on the roots are real and different, real and equal, complex. Depending on roots, how to write general solution you have to remember. Then only you can solve the problems. Are you getting? So this is my third problem. So this is my third problem on higher order differential equations. So let us move quickly to solve more problems, guys. The next problem is d power of 4 plus 8d square plus 16 of y is equal to 0. That is auxiliary equation. At place of d you have to substitute m. So what you get, m power of 4 plus 8m square plus 16 is equal to 0. That is m square whole square plus 2 into 4 into m square plus 4 square is equal to 0. This is a square plus 2ab plus b square is equal to 0. That is a plus b whole square is equal to 0. That is m square plus 4 into m square plus 4 is equal to 0. That is m square equal to minus 4. M square is equal to minus 4. M is equal to 0 plus r minus 2i. M is equal to 0 plus r minus 2i. Very easy, you see, very easy. Just like quadratic equation we solve. But what are the roots? Roots are complex roots and they are exist in pair and they are existing in twice. So already in a solution slide I given what is general solution. What is alpha here? 0 and beta is 2. So what is general solution? E power of 0x into equal roots. That's why c1 plus c2x into cos 2x plus c3 plus c4x into sin 2x. E power of 0 means 1. Therefore the general solution is c1 plus c2x into cos 2x plus c3 plus c4x into sin 2x. Are you getting? Very easy, just like quadratic equation. If the factors are possible, just write m power of 4 is m square whole square. That gives answer. Very easy. Very easy. Now similar to that, the fifth problem is d square minus 1 whole square of y is equal to 0. Just write auxiliary equation. What is auxiliary equation? M square minus 1 whole square is equal to 0. That is m square minus 1 into m square minus 1 is equal to 0. That is m square is equal to 1, m square is equal to 1, m is equal to plus or minus 1, m is equal to plus or minus 1. That is 1 comma 1 are two equal roots and minus 1 comma minus 1 are two equal roots. Therefore, for 1 comma 1 equal roots, what is the general solution? Y is equal to c1 plus c2x into e power of x plus minus 1 comma minus 1 equal roots. The general solution is c3 plus c4x into e power of minus x. Overall, what is the general solution? The general solution is c1 plus c2x into e power of x plus c3 plus c4x into e power of minus x. Are you getting? So these are the two problems I covered very quickly because they are very easy. You can see here. So d power of 4 plus 8d square plus 16 of y is equal to 0. That is m power of 4 plus 8m square plus 16 is equal to 0. That is m square whole square plus 2 into 4 into m square plus 4 square is equal to 0. So in which form you are writing? We are writing in a square plus 2ab plus b square is equal to 0. That is m square plus 4 whole square equal to 0. So complex roots which exist repeated twice roots. How to write the general solution? You know it. Very easy problem. Though the order is 4 and roots are 4 and solvation finding roots is very easy as like quadratic equation taking factors and common, or you can write a plus b whole square form and just write. You can write it down. Nothing is there. Very easy. Are you getting, guys? Are you getting? So this is a fourth problem. I solved very quickly way because it is very easy. If you want, you can look at the slide for 2 seconds, few seconds. Any doubt you can ask. So what is here is, I given already in solution slide. This is a way we have to write the general solution if roots are complex and repeated twice. But e power of 0, x is e power of 0, that is 1. Therefore, The general solution is this: c1 plus c2x into cos 2x plus c3 plus c4x into sin 2x. Are you getting? So this is my fourth problem. I already covered the fifth problem also very quick way, because fourth and fifth are very easy. But why given in the slides means they are repeated questions for 5 marks. So they are repeatedly coming for 5 marks. That's why I given in the slide, I put included in the slide. You see here, d square minus 1 whole square of y is equal to 0. Axillary equation m square minus 1 whole square is equal to 0. That is m square minus 1 into m square minus 1 is equal to 0. M square 1 means m is equal to plus or minus 1. So pair of roots 1 comma 1 equal roots, 1 comma 1 equal roots, and minus 1 comma minus 1 also equal roots. For first pair 1 comma 1, you write c1 plus c2x into e power of x, plus second pair minus 1 comma minus 1, we can write c3 plus c4x into e power of minus x. That is our general solution. Until now you are able to find the roots very easily. You can take factors, or you are using a cube minus b cube formula or a plus b whole square formula like that. But now the different problem I want to give. So how to find the roots? If there is no factors, no common term, then how to write the roots? So this is a problem, you see. Solve d cube y by dx cube plus 3 into d square y by dx square plus 3 into dy by dx plus 2y is equal to 0. Third order, put m at d by dx is equal to capital D in operator form, and in operator D you have to write m. So what you will get, auxiliary equation is m cube plus 3m square plus 3m plus 2 is equal to 0. M cube plus 3m square plus 3m plus 2 is equal to 0. You cannot take common. If you take common m cube, then first two terms, if you take m square common, then m plus 3. In the next two terms you won't get m plus 3. Are you getting? If you take the common first two terms, next two terms, no common factors. M plus 3 you will get. Here you won't get m plus 3 in next two terms. That's why the common in previous problems we did taking common, that is not works. Now by using trial and error, put m is equal to 1, put m is equal to minus 1, put m is equal to 2, m equal to minus 2, m is equal to 3, m is equal to minus 3, and so on. So from trial and error method, find the root. Now if you put m is equal to minus 2, that is minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 2 equal to 0, you will get right side 0 and LHS also 0. That is clearly m is equal to minus 2 is a root. So try to find one root by using trial and error. Substitute 1, substitute minus 1, and then 2, minus 2, 3, minus 3, 4, minus 3. Only if in first 4 or 5 trials you are going to get a root for our problems. So we got m is equal to minus 2 is a root. Now use synthetic division method. So what are the coefficients? The m cube coefficient is 1, m square coefficient is 3, m coefficient is 3, and constant is 2. M equal to minus 2 is a root. So write the coefficient in first line. Write the coefficients in first line. Are getting? So these are the coefficients. These are the coefficients, and m equal to minus 2 is a root. Now we are using synthetic division. Put 0 here. Put 0 here. Okay. 1 plus 0 1. 2 into minus 1 minus 2. 3 minus 2. 3 plus minus 2 is 1. Minus 2 into 1 is minus 2 again. 3 plus minus 2 is 1. Again minus 2 into 1 is minus 2. 2 plus minus 2 is 0. Last term you will get 0 because m is equal to minus 2 is a root. We are dividing with minus 2 means you get a remainder 0. So last term is 0. So this is how we find synthetic division. Now m plus 2 and the coefficients are now starts with instead of m cube we divided with m. That's why instead of m cube it starts with m square. So m square plus 1 into m plus 1. So what will get? M square plus m plus 1 is equal to 0. M is equal to minus 2, and use the no factors. Therefore, use the roots formula minus b plus or minus square root of b square minus 4ac by 2. So the roots are, what will get, m is equal to minus 2 and m is equal to minus 1 by 2 plus or minus root 3 by 2i. The first root is real root and the second two roots are complex roots. For real root you can write c1 into e power of minus 2x, and for complex root you can write c2 into e power of minus 1 by 2x into c2 cos root 3 by 2x plus c3 sin root 3 by 2x. First we written c1, then you have to write c2 and c3. If another term, then you have to write c4, like that. Are you getting? This is synthetic division. So what you are doing, just write the coefficient, m cube coefficient, m square coefficient, m coefficient constant, and from trial and error method find the root. We got m is equal to minus 2, then divide by m is equal to minus 2. But first put 0 here, then add 1 plus 0 is 1, minus 2 into 1 is minus 2, add again you will get 1, minus 2 into 1 it is minus 2, add you will get 1, minus 2 into 1 minus 2, add you will get 0. The last term will be 0 because you are dividing with the root. So after division, take these three are coefficient, but 1 degree, 1 order is lesser because m cube is divided, therefore it starts with m square. So m minus 2 is a root, that is m plus 2 into the coefficients are 1 comma 1 for quadratic equation, m square plus m plus 1 equals 0. So then find the roots, then write the general solution. So this is how we find general solution. If that we cannot take the factors, or we cannot take the common, or we cannot use the formula like a cube minus b cube, then by using synthetic division we find roots and we write general solution. So as time is left 5 to 6 minutes, so let us try to cover one more problem. Where it is? Yes, this is. Yes. Oh, what is happening? Let me cover one problem. Yes. The seventh problem, solve d cube minus 6d square plus 11d minus 6 of y is equal to 0. Axillary equation m cube minus 6m square plus 11m minus 6 is equal to 0. So again you cannot take any common term. If you take m square common, here you will get m minus 6, but in this you won't get m minus 6. So that's why what to do, from trial and error find one root, that put m equal to 1, minus 1, 2, minus 2, 3, minus 3, like that. By m is equal to 1 itself you got the root. Now take the coefficients, m cube coefficient 1, m square coefficient minus 6 and m coefficient 11 and constant is 6, divided by the root m is equal to 1. So put the 0, 1 plus 0, what is that? 1, 1 into 1 you will get 1. 6 minus 6 plus 1 minus 5, 1 into minus 5 it is minus 5, 11 plus minus 5 6, 1 into 6 it is 6, minus 6 plus 6 minus 6 plus 6 0. The last term will be 0 because we are doing, we are dividing with the root. So now what are the coefficients? M minus 1, m is equal to 1 is a root, m minus 1 into, now cubic equation is converted into quadratic because we divided, and what are the coefficients? Coefficient of quadratic equation is 1, minus 5, 6, the equation is m square minus 5, 5m plus 6 equal to 0. 5m can be written as minus 2m minus 3m because if you add you will get minus 5 and if you multiply you will get 6. Take m common, you will get m minus 2, and take minus 3 common you will get m minus 2. Take m minus 2 common you will get m minus 3. So what are the roots? M minus 1 into m minus 2 into m minus 3. The roots are 1, 2, 3. 3 real and different roots. The general solution is c1 into e power of x plus c2 into e power of 2x plus c3 into e power of 3x. So this is a synthetic division method, very easy method. Are getting? So if there are no factors, then from trial and error find one root, substitute 1, minus 1, 2, minus 2, like that you will get one root. By using that root, just divide, take the coefficients, take the 0, add and multiply like this, you will get the last term is 0. Then m minus 1 into the other coefficients of quadratic equation are 1 minus 5 6. Then you can write that is cubic equation is converted into quadratic. Take the factors and find the roots, then write general equation, general solution. This is how we find general solution. If there are no terms to take common or not in any formula, then we will find one root in trial and error, and we divide the equation with that trial and error root, then you will get other roots. That's it. So this is what we covered, that is higher order differential equation, solving higher order differential equations. So you will get number of roots 3, 4 like that. In case of 3 roots, in case of 4 roots, how to write the general solution, that's what we have seen. You will get 5 marks from this topic. So now let us try to give homework. Okay, homework. Before going to homework, what to do? You first of all go to the slide where the roots are given and how to write the general solution. If roots are given, so depending on roots, how to write the general solution is given. So read that. After going through that slide, then try to practice all the problems. At about how many we covered? We covered at about 7 problems. So try to practice those 7 problems. So understand how to solve. In case of different roots, one root is real and other are complex, and one root is real and other are real and equal roots, and 3 roots are different and 3 roots are equal. There are many cases of existing roots. So how to write, depending on the roots, how to write the general solution, that you learned by practicing the problems. So try to solve all 7 problems, practice all the 7 problems, and if you are having then only go for homework. So this is my homework. Solve y triple dash. Y triple dash means dqy by dx cube. So notations may be many. Y triple dash minus 9 into y double dash plus 23y dash minus 15 of y is equal to 0. So excuse me. So here you cannot take common. So no common terms. So you have to use synthetic division method. Whereas in this second problem, you can take m square common, you will get m minus 2, minus 4 common, you will get m minus 2. So just directly you get roots. Here you have to use synthetic division. Here a cube plus b cube formula. A plus b into a square minus ab plus b square is equal to 0. So you can do the homework and try to do, first of all, practice the given problems, given solved problems, then try to do homework. And if you get any query, for any queries, you can mail me at naresh.debody@gmail.com. And after doing homework, you can post your homework in Google Classroom also, so that I can quickly respond you and verify your homework problems. And if you have any queries, you can mail me or you can post in Google Classroom also. Are you getting, guys? So this is what we covered in this class, that is higher order differential equation. In particular, higher order homogeneous linear differential equations with constant coefficients. So what is the key point here? If you know the roots, you have to write the general solution. So first read them. Depending upon given roots, how to write the general solution. Then in problems, try to learn how to find the roots. That is it. Next class we are going to cover non-homogeneous differential equation. Non-homogeneous means right hand side is not 0, it is some constant or function of x. So next class we are trying to cover non-homogeneous differential equation, which is a more important topic. So until that, bye, see you guys. Thank you very much. Stay home, stay safe, stay healthy. See you tomorrow.